Hello guys, good morning. So coming to your financial management subject, just go with Himalaya publications, okay? According to me, this is good. Second year, third semester, okay? Just look on to the units which are important, okay? So coming to the first unit, just go with completely of theory. Prepare well for theory of completely, okay? Don't even skip an point two, okay? Complete unit you just thoroughly you just read. And next, coming to the second unit, you'll be having two methods, like two types you'll be getting: a concept of time value of money and capital budgeting. So from this you'll be getting capital budgeting theory and as well as a problematic, okay? You can consider theory as well as a problematical. So time value of money, one question definitely, and capital budgeting, one question definitely you'll be getting from the two topics. So concept of time value of money, just let us go detailedly, okay? Second unit, see time value of money. Here time value of money, as you all know, in this only two topics will be covered, which is future value and present value. Time value of money, according to the time of the value, according to the time the value of the money will be described, okay? If take an example, if you have 100 rupees now, and that 100 rupees again which is given or which is received will become a double or else extra amount including the interest according to the time taken by that amount, which is like month or a year or any, okay, next day, anything. That is nothing but time value of money. Than today's amount, the value of the future amount is more. That is nothing but your time value of money, okay? You'll be having more value of today's amount to the future value, okay? Future amount, that is nothing but your time value of money. And next topic in this second unit itself is a capital budgeting. That is your capital which is invested in the fixed assets to be exercised accordingly by the budget, okay? So this is one type and this is one type. Definitely one theory and a problem on time value of money or capital budgeting, but definitely you'll be getting theory as well as a problematic. First, next you see as in this time value of money we have two methods, which is, see here we have two methods, which is calculation of techniques in time value of money. So in this part of time value of money, two methods, which is FV and a PV. FV is nothing but future value and PV is nothing but present value. So first let us go with the techniques. Two techniques are nothing but compounding technique and a discounting technique. So compounding technique, compound, we are togethering, okay? We are getting together, the amount is getting together, we are compounding, okay? That is nothing but in simply we can call it as FV. Compounding means FV. Discounting, that you are getting a discount, okay, which is the future amount is very less, okay? That is nothing but PV, okay? Present value, okay? That is nothing but your discounting method. Compounding means future value, and discounting, in the question if we give any discounting, then that is nothing but he is asking indirectly regarding the present value, okay? Present value. Next you see as compounding the future value of a single present cash flows, future value of annuity, where you will be having some techniques of compounding and discounting. So in this you have a single present cash flows, which is nothing but stable, okay? Which is nothing but single means like annually your payment is fixed, okay? In this way, stable, okay? Your cash flows are stable. And next the future value of annuity series of cash flows, and next one is the future value of multiple cash flows. We have some terms like PV and FV here, the extra amount of it. Here you see as, let us go with the future value, compounding technique na. So in that compounding technique, future value, we have formula. So what is that formula? Formula is FV is equals to future value na. So today's 100 rupees, in the future how much it is becoming. Okay, so we have formula, FV is equals to PV into 1 plus R whole power n. Okay, FV is equals to PV into 1 plus R whole power n. So future value is equals to present value of today's 100 rupees into 1 plus that rate he will be giving, because with that rate of interest only we will calculate the future value, because the amount of 100 rupees is charged with the 10% or 12% according to the question he gave in based upon the years. N is nothing but years. So if we consider this, that 100 rupees of today will become the amount increased in the future. So blindly just one point here is, in the compounding technique future value will be more. Okay, just listen carefully. In a compounding technique, future value is more. Okay, it is more. Discounting technique means your present value will be less. Okay, your whatever you are getting, the amount which is before only treated, like in the future of after 10 years you will be getting this much of amount as 10,000, then that amount will be 10,000. That amount you will be, if you calculate, you will be getting it as 8,000 change. In that way he will be telling us future you will be getting 10,000. So that amount if you calculate for PV, then it will become 8,000. So the specifications of 10,000 becomes a 8,000 because it is a discounting technique. Okay, discounting techniques of present value. Is it clear, ma? So future value is nothing but PV into 1 plus R whole power n. So here you see as, this is the formula for calculation of future value. Okay, when it is rupees 100 or anything. Okay, next you see future value of a single present cash flow can be FE. Yes, single present cash flow. The same formula, single present. FE is equals to PV into 1 plus R whole power n. That is here when it is single present cash flow. And when it is next you will see, yeah, see this is the problem where we will be having in this way. Find out the future value of a sum 2000. So he is asking here, find out the future value. Future value he is asking of a sum of 2000 after a year with time preference money of 12%. So future value is equals to PV into 1 plus R whole power n. So find out the future value. Future value he is asking for us to find out of a sum of 2000. Okay, PV is how much? 2000 after a year with the time preference money of 12%. So PV into is how much? PV is 2000 and interest is 12%. Okay, interest is 12% and n is how many years? Year. Only 1 year he specified. See, n is 1 year. This is 1 year. Okay, this is n, because it is said that single present cash flow, not for 2 years or 3 years. Okay, it is for 1 year. We can take, if at all, if it is for 4 years or 5 years, we can take it as n in the place of n, 3 or 4 or 5. Okay, next let's go with the second illustration. See, here he gave as n is equals to 3 years. Okay, n is equals to 3 years and n is equals to 3 and invest rupees 1000 for 3 years. So now he is investing. Okay, that is nothing but now he is investing means PV means present value na. So PV is 1000, n is equals to 3 years and pays is 10% interest. How much it is? Interest is 10%. per annum, how for month yearly. Okay, calculate the future value FV. FV is equals to PV into 1 plus R whole power n. Okay, this is the formula. See, you can also consider in other books. Okay, from other books it is there that V1 is equals to V0 into 1 plus I. Okay, V1 is nothing but your present value. V0 is nothing but your future value. Okay, V0 is your see future value of the first year, second year, and you can also consider this as V1 is equals to V0 into 1 plus I. So V1 we don't know, as V0 is equals to, that is V0 for first year it is 1000. Okay, and into 1 plus is 1.10, 1100 for first year, 1210 for second year, and 1331 for third year. Okay, same way. Okay, if you consider this also, it will be in the same way. Okay, is it clear, ma? This is the formula of one more type. Just consider, if you want you can consider this only, PV into 1 plus R, whichever is easy, you just follow that. Is it clear? Next one you see as, let us go with the second method of second case. Okay, in case of multiple compounding, see, as here it is told that in a case of, see, when the amount is stable, like yearly the payment is stable, 1000 means yearly we are paying a same amount. In the case of compounding period or intra compounding, okay, in the case of multiple compounding, see here it is there as multiple compounding period. So FV is equals to PV into 1 plus R by M whole power Mn. This is the formula when it is for multiple compounding period. That is FV is equals to PV into 1 plus R whole power n it should be, but here M is increasing, that is multiple compounding. Okay, first case is just in a normal single way. It is when it is for multiple compounding period, it is in a different way. So that will be in the case of, it will be payable half yearly, means 1 plus R by half yearly na, means in a year 2 times we need to pay, 6 months kokasari, 6 months ki inkosari, so by 2. If it is payable quarterly, so yearly 4 times we will pay, that is 3333. Okay, like that we will be paying 4 times, 3 months, 3 months, 3 months, 3 months, so 4 times we will be paying. Interest is payable monthly. Monthly means how many months? 12 months in a year, so this divided by 12 into n. Next, when it is payable daily means daily you are charging an interest, so it will be different. That is nothing but your compounding in a multiple ways, only your half yearly, quarterly, monthly, and daily. Daily means 1 plus R divided by 365. Okay, 365 days. Now we are considering here days, so only 365 into n. N is nothing but your how many mostly 365 means 1 only, 1 year na, 365 into 1. So in this way, this is second case. When it is stable, PV into FV is equals to PV into 1 plus R whole power n. When it is multiple, FV is equals to PV into 1 plus R by M whole power Mn. This is your formula. Only M is included here. Is it clear, guys? Just a simple logic. Just don't forget it. Okay. Next, third one you see as third method. Okay. See here, this is the next part where the future value of annuity. Okay, annuity. Let us go with the annuity. Okay, till now we have discussed only the future value. So now the future value of annuity. Annuity is next method. This is also one type. Okay, in that future value of normal, we have seen 2 to 3 times. This is the second part of B, which is future value of annuity. Annuity, you see here, it is nothing but even cash flows, means 1000 even cash flows. The cash flows for 5 years, 1000 is fixed. Okay, 1000 or 2000, whatever it is in any that even cash flows for first year 1000, for second year 1000, third year 1000, so on and so forth till 5. Thus that is nothing but even cash flows. Okay guys, this is nothing but your even cash flows known as annuity. See, even cash flows of a certain period of time, how many years, any like 5 years or any years, okay, of time is known as annuity. So annuity, for what? You will be having a future value as well as for present value also you will be having an annuity. Okay, in other words, annuity is a fixed payment. See, once again it is saying that it is fixed payment or received each year for a specified number of years. The future value of annuity can be calculated by using annuity table. This will be done by the usage of annuity table. Okay, future value annuity table. You need to consider the future value annuity table. So let's see the annuity table over here. So for this you have different formula. See, you can consider anyone. See, you have a future value of annuity. Why are you specifying here annuities? Because of fixed payment of the amount for years, like 1 2 3 4 5, same amount. Okay, you have to you can consider as A into CVFA into RN. Okay, A is nothing but your annuity, and your CVFA is what is the compound variable factor. Okay, compound future value will be there now, compound table factor, compound variable future value, future annuity table. If you go ahead, as in this book it is not there. Okay, you will be having in your text, your series or any book. Okay, CVFA, there you have to consider. Okay, FVA, or one more formula is there. FVA is equals to R into 1 plus I n minus 1 plus R into 1 plus I n minus 2. See, same amount but it is increasing. Okay, same amount, R into R is fixed over here. What is the R value? Even cash flow. See, R is nothing but even cash flow. So only here it is telling us R is fixed. How much? 1000, and again 1000. In this way you will be getting it. Okay, this is nothing but your future value of annuity when our annual cash flows are stable. Is it clear, guys? Okay, next we'll go with when our annual cash flows are not stable. Okay, when our annual cash flows are not stable means uneven, not stable. Okay, let's see this. Yes, just look on to here. As you have future value table, it is a normal table with future value, and next is future value of annuity, whatever we are discussing now. Okay, whatever we are discussing now, future value of annuity. And one more you have is present value. Okay, present value table, and this is nothing but your compounding factor, and this is nothing but your discounting factor. Okay, and one more is present value of annuity. Okay, is it clear, guys? Only two tables we have, which is future value and present value. In that only future value annuity table, future value table, and present value annuity table and present value table. Only four, like two methods, like two types of future and present, and annuity there and annuity here. Okay, this is nothing but your tables. These are your tables. According to this, by the years only we have to consider the percentage. Here he will be giving a percentage of interest rate. Okay, if at all 8% or 9% or 10% if we charge, according to that 10% we have to consider the years. How many years are there? See, for example, if it is for 8 years, 8 years 10%. Example I am telling, 8 years 10% means 11.453. Okay, this is the point. Okay, this is your 10%, 8 years. Okay, 11.435. Like this you have to consider. Okay, is it clear, guys? Okay, next let us go with the second part, which is future value uneven cash flows. Uneven, till now we have discussed with even cash flows, that is stable. Stable means R will be same. R will be 1000 here and 1000 here and again here 1000, but here same formula, but R will be different. Okay, R will be different, like it will be R1, R2, R3, R4 and R5. R is nothing but your value. How much it is? 1 year it is 1000, second year it is 2000, third year it is 3000. In that way he may give. That is not even, it is uneven cash flows. So formula will be different. On same formula, only the changes you should do is R1, R2, R3, R4, because it is different for year and year. Okay, there the R is stable, R only we kept R, but here year wise so only you are writing year wise different amount. R1 first year how much? See in the table you see as R1 how much it is? 2000. See 2000. R2 is how much? 4000. So R2 it is 4000. R3. Okay, in that way you have to calculate your future value. The present value how much he gave is yearly wise. R1 is 2000, R2 is 4000, R3 is 6000 and R4 it is 8000. Is it clear, guys? Okay, in this way you have to consider when it is not stable. Not stable means uneven, not same. Okay, so, okay, this is completely of future value. Next we will go with the present value. We have for present value different formula. That's it regarding the future value. Is it clear? Okay, next we will be going with the present value. Present value we have PV is equals to formula. Okay, PV is equals to FV divided by 1 plus R whole power n. So present value if you want, that is future value, you are telling now only that in future I will be getting 30,000. So now only you are considering it. Future how much you are getting, that now only you are telling it, that PV is equals to FV divided by 1 plus R whole power n. So with this it is nothing but discounting, na? Discounting technique. Discounting techniques. So discount means, see by the name itself it is knowing, blindly fix it, ma. PV, you are considering PV means discounting techniques, which you will be getting less amount. Okay, you are not expecting more. Okay, you are expecting less. If it is 30,000 in the future, you are expecting 30,000, but you will be getting as 28,000, which is 2,000 discount. Is it clear? Okay, and next formula you see as PV is equals to FV divided by 1 plus R whole power n. This is the formula for PV. Okay, general regular formula of PV is equals to FV divided by 1 plus R whole power n. Okay, this is the formula. See, small example here he gave. Value of n is small. Find the PV by solving the equation without help the logarithms. For example, PV is equals to FV. How much? 110 divided by 1 plus R. 1 plus, see, 100. Future it is 110. You are expecting as in future I will be getting 110. But now if we see, now if you calculate how much you are getting, you see as only 100 rupees. When you calculate it, but you are expecting much in the future of 110 you are getting. But when you calculate it by considering the 1 plus R with interest, then you are getting only 100 rupees. See here, 110 is where you are expecting, but how much you are receiving as 100 rupees. Okay, in the future of Now you have calculated before only that 110 I will receive in the future, but when you calculate how much you are actually receiving is only 100, so only it is telling us discounting. See, out of 110 expectations only 100 we received, that is nothing but discounting. So expectations is more than what you have received, that is nothing but only you are discounting. So blindly in the calculation of future value your amount is more, in the calculation of present value your amount is less. Is it clear, ma? This, don't forget this logics over here, these are all small tricks. Next one you see as PV technique or discounting technique. Okay, in the question he may give as discounting technique or PV technique. Okay, in that way he may ask, or in a sentence frame formation of a question also he may ask that present value or future value in that way. Okay, you have to think of it, you have to consider whether it is a PV or a FV. Okay guys, next, present value of a single cash flow, that is stable. Same single, it's like general fixed na, single means say amount is fixed for 1 year, amount is fixed 1 year. What is the formula? PV is equals to FV divided by 1 plus R whole power n. This is the formula, easy formula. When it is FV we need to calculate PV into 1 plus R. When it is PV, see FV is equals to PV is equals to FV divided by 1 plus R. This FV is coming this side and it is becoming as division. Here division, now it is becoming as, here multiplication, so it is coming this side, so it is becoming division. Okay, if you know this perfectly of PV, then definitely you will be knowing this FV. Okay, by solving it, PV is equals to FV divided by 1 plus R power whole power n. How did you get this? I'll explain you. FV is equals to PV into 1 plus R na. So FV you know, you want to know PV, so PV is equals to PV na. So PV is equals to, or else let it be this side only, PV is equals to FV, this PV is equals to, let it be with this only, here this side only. Okay, FV is equals to PV into 1 plus R whole power n. FV is equals to PV 1 plus R whole power n. Then you need PV. So PV is equals to this 1 plus R is becoming, here it is multiplying now, so here it will become as division. So FV divided by this plus F will become minus, this PV this side it will become as minus PV is equals to minus FV divided by 1 plus R multiplication means here it will come as division. So 1 plus R whole power n. Okay, minus PV is equals to minus FV by 1 plus R whole power n. This minus gets cancelled. Okay, minus gets cancelled. So complete formula finally it is PV is equals to FV divided by 1 plus R whole power n. In this way you got this formula as PV is equals to FV divided by 1 plus R whole power n. Simplification. Okay, or else if you want you can buttify too. Okay, next one more also you have, just consider this only, Okay, one more also we have is PV is equals to FV into PVF. This is present value factor table. I showed you na, present value factor table and present value annuity factor table. We have two types, which is normal table and annuity table. Okay, that you need to consider. Is it clear guys? This is the first. When it is single cash flow, when it is compounding period, your formula will be PV is equals to FV divided by 1 plus R by M whole power mn. There it is multiplication, here it is division. That's it. Okay, did you get here? So PV is equals to FV divided by 1 plus R by M whole power mn. or you can also consider as, see, go with this only, okay, or you can also consider as FV into PVF by R by M into N, in this way. This is very complex, this only easy, okay, according to this formula, you just go in a compounding period when it is multiple in this way. Is it clear, ma? Okay, next one you see as we have present value of annuity. Here again annuity is there. Annuity means again amount is fixed. Okay, like amount is fixed for period of years like 5 years, or that is nothing but your annuity. That PV of annuity, a series of equal or unequal, anything, or even or uneven. Annuity is payment of amount yearly wise. See, so PV itself is division way. So you just consider PV is equals to P1 divided by 1 plus R whole power 1. You can also consider as only P. Okay. Here P1 is there now. You can consider it as P. Okay. P1 and P is nothing but same. P1. You can consider as P, only P, because it is fixed. So consider it as P. How much is P? If you take an example of P is 4,000. So 4,000 for all 4 years. 4,000 divided by 1 plus R whole power 1 and 2 and 3 and 4. In this way you need to calculate. When it is fixed, your 4,000 amount is fixed for 4 years. Okay. So only you are taking as 4,000. When it is not fixed, okay, when it is not fixed, see, this is the third type, uneven of PV calculation. Okay, PV of uneven, not stable. Then you have to consider P1, P2, P3, P4, P5. See what he is telling. P1 is 2000. Okay, this is P1, P2, P3, P4 and P5. Okay, this is nothing but your unstable. Okay, this is the formula. Unstable, it is same as FV, but here division is going on. That's it. Your PV is P1 by 1 plus R whole power 1, P2 divided by 1 plus R whole power 2, and that is N is 2 years, 3 years, 4 years and 5 years. Okay, this is the formula for when it is uneven cash flows of annuity method. Is it clear, guys? So this is very, very important. Next one you see as you have annuity even a short method also. Okay, you have a short method, which is this short method, okay, not a very large method, it's a short method. That S is equals to A into 1 plus R whole power N minus 1 divided by R. Okay, instead of doing this lengthy process, if you consider in this, then it will be so easy. Okay, if you want to do it, you just consider it, or else if you want to prolong in this way, then go with this only. Okay, your annuity type when according to your FV you have this. Okay, FV's formula when it is annuity in the shortcut method. Okay, this is shortcut method. Don't get confused, guys. This is a shortcut method of calculating your FV at annuity. Okay, listen carefully. FV at annuity, shortcut method. PV at annuity. See, this is the PV at annuity. This is your PV at annuity. Okay, consider this. This is also for shortcut. If you consider shortcut method, then only it will be say, or else if you don't want to consider also, just go with this direct format. Okay, in depth large format, annuity of PV and annuity of FV. Is it clear, ma? This is regarding time value of money, future value and present value. Present value you can call it as discounting, and future value you can call it as compounding. Is it clear, ma? These are small points where you have to present value as discounting, yes, future value as compounding. These are the small tricks you have to remember. Okay guys, thank you for today. Tomorrow I'll next again in the next video I'll go with the cash budget, capital budgeting. Okay, this is the next topic in the second unit itself. Okay, second unit you have. Thank you guys.